Okay, we continue. We now start with the new chapter. Which is chapter 6, but on my slide is chapter 7. Right, but for okay. So we're still looking at rigid body. Yeah. So we already done F equal to ma. Yeah. And now we look at work and energy. Yeah. Already done F equal to ma. Today, now this section we look at work and energy. Yeah. Okay. What is work again? What is work? When your force is moving a certain distance, then you're doing work already. Yeah. F multiply S, having doing work. As long as your force got touch something and then moving, then it's doing work. Okay. Energy, you learn 3 types of energy: kinetic, potential, spring. Okay. So we're repeating the same thing. But now we focus on, because of rigid body, we focus on the center of mass. Okay, this one I think I'll go very, very fast. Okay, this one you've seen before. This one you go home and read. It's still the same. Kinetic is what? Half mv square. Nothing new. Half mv square, still the same. You see the I there is individual particles, and then you add all the moment, all the mass together, and you get the energy. Yeah. So this one, Ti is individual little dot plus half dm of that particular and V of that particular. All right. So you add all the energy together, get kinetic. But still we arrive at T equal to half mv square. Still the same. I won't test you. I won't test you on the thing. This is for your info. Just for info. Don't panic by the vector. I won't test you. I won't test you, but at least you've seen this before. You've seen this slide before. Okay. Half mv square kinetic energy. And because we are focusing, mass normally is constant. Right? So one is changing is the velocity. So if you're referring to this diagram, and you're having a velocity vector of Vp, Vi, and you combine the Vp and Vi, still again, it's a reference relative velocity. If you have Vi slash P, you just convert the slash become negative. Okay, Vi slash P equal to Vi minus Vp. Then you rearrange back the equation accordingly. Depend on what you want to calculate. Okay, as long as you need to find Vi slash P, means you change the slash become negative. Vi minus Vp, then you rearrange based on the need of the question. Okay, the rest is just vector form. This is for your reading. Not, I'm not going to test you this one. Okay, this one for your reading. Reading. It's quite lengthy. The derivation is quite lengthy, but I'm not testing you the mathematics. On these slides, it's a bit different from the particle chapter 1, 2, 3, 4. But we go into rigid body. You'll be seeing the effect of mass or center of gravity, center of mass. That's why you see you need to find the average location of that, the bar X, bar Y, and so on. Okay. I will skip very. Okay, this one, you copy this equation for the kinetic energy part. You have a few components. So this one got one component, I highlight in yellow. Second component, third component, and the fourth component. You have four components in kinetic energy of a rigid body. You have four components. So this one, no worry. If the question come out, I will give you this equation. What you need to know is you need to find the effect of mass. The first one, half mv squared that you learn in your static or your physics class. Because in your physics class or in your secondary school education, you ignore the rest of this one. You only do this one, half mv squared. Okay, this one represents the entire mass effect. The second one and the third one, you see y and x. This one is the body center of mass, means the y bar and the x bar on the average location of your center of gravity. Right? So this one is the previous one in your static or mathematics. You build a table that you find your at the end you find what all the xi mi equal to x bar m, and then you find at the end you get what is your location of your x. So the middle, the second term and the third term basically is to find the effect of your center of mass. Mean you'll find x bar and y bar. Okay, but we're not going to do that in dynamic. It's just that you need to know there is an effect of body center of mass. Okay, the first term is entirely mass. All the mass add together, it will create energy. And that one is the effect of center of mass, G, to the reference point somewhere on the body. Yeah, this one is referring to the central point, the interest point to the body where maybe your feet to your eyes, for example, on the same body. This middle one is the same, or we call it internal energy, the internal initial momentum kind of things. Okay, the third one is moment inertia effect. Okay, so there are three effects basically, but you have four terms. The first one is entirely mass effect, M, where is a basic one. The last three terms is actually the internal body energy. We call it internal energy. Okay, consists of body center of mass effect and moment of inertia effect. In the previous chapter, chapter 5, chapter 6, you try to estimate seeing the effect of center of mass, and also you look at the effect of moment of inertia in the previous section. Now we combine, we pull in all these two, the two terms here, body center of mass effect and the moment inertia in this chapter to find the kinetic energy. Yeah. So basically, you need to memorize this kinetic energy equation for chapter 7. Standard form, standard form. Right? Or if this question come out, I will give you this equation. But you need to know what is what lah. Need to know what is what Okay. Okay, so in summarize, you get the first one, half mv squared. Second one, the question might be ask you to find the effect of energy of the body center mass at G, where you take VPX omega y bar m. Meaning this one you read from a diagram, y bar, x bar, read from a diagram. Vpy multiply omega x bar m. And the last one, is the moment of inertia half omega square IP. Half omega IP. So either you memorize the first one or the second one, but again, this one will be given in the test if this question come up. Okay, right. So if you have this kinetic energy equation, in special case, if your point P, this one, your reference point P and the center of gravity, they are on the same spot. If this one, your interest point O or P is on the center of mass G, your x bar, y bar equals 0. These two, the center of mass here, x bar, y bar 0. So you arrive at the first term and the last term. Yeah, if your P move to this point G here, your x bar, y bar will be 0. And you arrive at this equation. Will be kinetic energy equal to half mv squared plus your initial moment of inertial effect. Okay. This Ig, read from the appendix. This Ig, read from the appendix. Depend on the shape. Either it's Ixx, Iyy, Izz, or I comma, comma, Iyy, comma, and so on. And both right-hand side are always positive because V always square, omega always square. Ig positive, velocity you square it positive, mass is positive value, so your kinetic always positive. Yeah. Yeah. So this one is you are referring to velocity at the center of mass, this one. And this one you are referring to rotational kinetic. So there are two moments, two kinetic energy. If your object just move in a linear motion, where you learn in your physics, there's no rotation. In your physics or SPM level, foundation level, half mv squared because your object always move in a straight line or fall in a straight line. That's why you learn half mv squared. But if your object move in a straight line and rotate, when you have rotation, you need to consider half omega squared I because of inertia. Yeah, so since you're in the aerospace degree program, you need to consider rotational effect if you rotate things. Because you are learning blade, turning blade, gear, wheels. In satellite, you also rotate around the Earth and so on. All right. And sometimes you retract things from the motor power. You are rotating the thread or the wire. So there is a effect of rotational kinetic energy there. Okay. So there are two effects. One is translation, means move in the straight line. If the object only move in a straight line, you only arrive at half mv squared. If you see the question mentioned is rotate, or you see omega or alpha in the diagram, you need to include this formula in the kinetic energy, half omega squared Ig. Yeah. Okay, this is just why if there's no rotation, the object move in a straight line, translation, then you only use half mv squared. So if you have a rotation, you see diagram got omega, you need to include I omega squared. Yeah, so if you have a rigid body rotate about a fixed axis passing through a point, means you fix a point and you rotate, usually your turbine jet, the blade, you need to use this one, the kinetic energy. Like for example, your wind tunnel, we design the blade. You need to use this one. Okay. Okay. So your velocity, you can also convert V equal to omega R that you learned previously. Your V, you can use, replace this V with omega R. Because on the realistic case, you're not able to follow your blade velocity, but you're able to measure the rotational speed. Okay, so we are converting Vg to omega R or R omega. Okay, so when you put in the term, you expand, what do you get? You get half m r omega bracket square plus half omega square ig. You factor the half and omega square. You get what? Mr square plus ig. What is this? Moment of inertia. I equal to ig plus mv square. Okay? So it just means if you have an object that is pinned to a point and rotate, your new equation that you learn in dynamics, your kinetic equation is half I omega square and no longer half mv square. If you have an object that pinned to something and rotate, like example, your aircraft blade, your kinetic energy no longer half mv square, but it is half I omega square. This equation combines two motion, translation and rotation, or we call it general plane motion. Yeah. So I put it just to memorize it. T equal to I omega square. This I won't give you. This equation I won't give you in the test or final exam. Is you need to memorize. T equal to I half I omega square. I won't ask you on the derivation. I just ask you to apply this equation in the question. Okay, now how to find IO? I equal to Ig plus Md square. This one, the R is referring to the reference point O to the center of mass. This one. Ig refer to the appendix. Okay, the rest you read. We're just repeating the same thing. So sometimes you can replace the IO with IC if you want, right? And we already explained to you how to draw the IC, right? Yeah, we already done for the kinetic. Okay, we continue. Okay, what is work? What is work? Force multiplied by the distance. The distance and force must go parallel. Only the product of these two will create work. Because we're dealing with vector. So your force and the path must go parallel, then only create work. Okay, this one is just a derivation that you have seen in your previous chapter. So what is important, this one you can skip. This one is just important. What is important is when you calculate the work, you always take force multiplied by the parallel distance. This one, the angle, this one you can ignore at this time. But when you do your work later, the work always take force multiplied by the parallel displacement. Okay. Now we always deal with work, weight. The work done by the weight in most of the time will be negative because we always put y positive go up and negative go down. And your work is always point down. All right, always point down. And if it's fall down, it go downward, the force done by the work is negative because your y is go down negative. So this is some of the careless mistake that you will see in tests. But you forget that if the object fall down, your work done by the object is negative. So this one need to be take care a bit because the displacement go down is a negative. Y is negative, not positive. But if you throw something up, the work done by the things that you throw up will be positive. But when it starts to fall down, it will give you negative work. So this is just take note. So this work, we use capital U to represent work. Work done by the weight. U, W means done by that force. In this one is weight. So where the weight always, you will get negative if it's go down. So again, negative sign, positive sign depend on the position. If it's go down from the reference point, then you get negative. Okay, weight, we are done. Again, repeat. What is work? Work when you take force multiply by the parallel distance traveled. Both must go parallel because both are vector. Force multiplied by the parallel vector of displacement F multiply S, then it create work. If your force and the displacement is perpendicular 90 degree, you get 0. There's no work done. If your force and the distance traveled is perpendicular, you get 0 force. Example of 0 force is the contact force of your tire. Your normal force of your tire always pointing one point, and no matter how it travel, it's always on one point, and they're always parallel. Okay, so need to take care, this one. Spring force. Spring force, you learned this one before. Spring force is negative work because it's half a k square minus half k square. Yeah. So just need to take note lah. Need to take note. Where here the magnitude of S2 is larger than the S1. Yeah. This is unstretched. Your S is unstretched. So if you pull your spring, and you press and then you unstretch. The spring either stretch or compress. So it depends on the previous position and the final position. S2 means final position. S1 is initial position, or the position come after the initial. Okay. Yeah. I need to explain why spring negative work. Just to recap, why spring work is negative. If you press a spring, let's say this is a spring, I'm the body. So if I walk to your right, I press a spring. So what is the force I feel? Compress, right? So the force go this way, but my body go this way. So the force and the displacement is opposite direction. So you get negative work. Okay. Even I unstretch, I pull the spring. I pull the spring, what I feel? I feel the force pulling away, but I walk back. So the displacement and the force I feel always opposite, also positive, always negative. Yeah. So the force and the displacement is opposite direction, so we get negative work. So that's why energy, sorry, not energy, work done by the spring always negative. Because the force and the displacement are different direction. So okay, now when do you create work? When you force and go with the parallel displacement. It's just a revision. Okay. One thing I want to mention here, if there is a normal force acting on that object, especially on a wheel or something, normal force do not create work. Normal force do not create work. Friction create work. Weight also do not create work. Weight of the round body rotating, weight do not create work. Because it do not displace any distance. It's always stay with that distance. The word here is without slipping. If you see the question mentioned, it roll without slipping, meaning friction do not do work. Without slipping means it continue to roll. If it slip means it will have some friction that it move at a certain distance. Okay, we are done with the work. Now we look at moment. Again, moment is force multiplied by perpendicular distance, F multiplied by the D. Okay. If we have an object rotate like this, clockwise, you can transfer this moment equivalent to this diagram, where you mark the center of gravity at the center, and then you can transform this moment into two forces that is rotate like this. You can convert this one, M, to these forces. It's a translation of this presentation to this presentation. Okay, when we need to convert this diagram to this, when you need to calculate the power of the motor that you use. Because you need to calculate the force that you need to generate the moment or the RPM. Yeah, so this one, perpendicular distance of this one, how you know, how you create this one is the perpendicular distance from here to here, you will generate moment. If you refer to here, R multiply perpendicular force, you get moment. And this F is 0 because distance is 0. If you put center, what is your R? Half R. So this one, F multiplied by perpendicular distance here, half R, plus this side, F multiply half R. You still get the same magnitude. So it depends where you put, but you must still get the full moment. This one is to calculate where you put your datum or where you put your weight lah. Sometimes you need to do balancing lah. Sometimes especially on the propeller, drone propeller. Sometimes you need to do balancing. Your car also, your car wheel also, they do wheel balancing. So they put the weight at a certain location to balance the wheel because the moment. Okay. Okay. So as you can see here, if you draw diagram, moment, you always have a cancelling force. One go up, one will go down. All the force will equal this one plus this one, 0. Okay. Now the rest is just bring back your mathematics. If you have something that rotate, you need to calculate the displacement here. You have a circular section here. S equal to R theta. S equal to R theta. So if you take your you need to calculate your ds because you need to calculate work, right? So what is work again? Force multiplied by the parallel distance, you get work. So how you find the parallel distance on the circular body? You calculate ds, right? How you get ds equal to R theta. So this is the thing lah. Okay. The rest is you read lah. The rest you read. So just now, we are converting the moment multiplied by the displacement of angle from the force to moment. The product of this one will give you moment. So to calculate the work done by the moment, is U equal to M theta. Maybe something new or just recap from the previous chapter. Moment also do work. Previously, we focused on force create work. Force, if you go parallel with the displacement, you do work. But if something moment, you have moment. Moment multiplied by the change of angle also do work. Means you have two motion. One translation, if the object moves in the straight line, then you have F multiplied by the straight line displacement. If one thing rotate in the angle, you have a moment, you take the moment multiplied by the angle, you get work also. Yeah, so in your SPM, you already learn everything in straight line. So you take F multiplied by the S. But in dynamic, you start to think rotational. So when you have rotational, you take moment multiplied by the angle, change of angle, you get work. Force only parallel distance, but moment you deal with angle. So you take the moment multiplied by the angle, you get work. Huh? ds? ds only work for force. So this ds actually is a section of the circle. So how you find section of the circle? How you find the circumference of circle? You take r multiplied by theta, right? Radian. S radian, you get s, the section. So you take s multiplied by the force, you get work. But for the rotational, more easier one, you take moment multiplied by the angle. Usually moment will be given. Unless the question become tougher, it only give you force, then you need to find the change of displacement here. Okay, this one you'll see in the tutorial. The rest is just mathematics. Go home and read. Yeah, so I just need to highlight force again. Force always deal with the linear displacement. If something rotate with the moment, you take moment multiplied by the angle, you get work also. Yeah. Okay, this example. Okay, we can, 1 o'clock already. Okay, no class? Have any class? No, what? Okay, this one then we call it a day. Okay, you look at this diagram, you have a spring. So spring do work also. Then you have a moment there. You are given moment multiplied by the angle change, you get work. You have a force there. Force P multiplied by the perpendicular distance, you get work. So we need to calculate 3 kinds of work: spring, force, and moment. So the rest is given in the question. Determine the total work done by that object, that system. So meaning you calculate P, it gives you what? From 0 to 90. 0 means at here. P will be at here. You need to imagine one by one. So when P at here, what is the distance traveled by this 90 degree? What is the distance traveled by the P? This one, the P. This is 90 degree to here. P traveled along the circular pathway. You know how to find this S, right? You know 90 degree. So how to find circumference? 2 pi r multiply 90 over 360 or 1 over 4. You get this displacement. So you have displacement. What is work? U done by the P will be force multiplied by the perpendicular distance. Force is given P. So this one P multiplied by this distance, you get work done by P. Okay. Second one, spring. Spring, you know lah. You need to also imagine how much is stretch and so on. Moment, you don't need to calculate. Moment, work done by the moment is what? Moment multiplied by the angle change. 90 degree. So multiply by radian. Okay, you see the work. Go home and have a look. This will be the complete free body diagram. What is the mistake done in the exam or test? You will forget the W. This one, as you go deeper, you always forget the W because the question do not give you the mass, the point of the central of mass. Okay, all this you go home and have a read. Okay, have a read. Yeah, so we done weight multiplied by the distance, spring, you calculate how much is stretch. Okay, how much is stretch when it's 0 here? It was given in the statement just now. So you find the original, this length, and then 90 degree, how much is stretch? So this one need to think a little bit, the spring. And stretch, how long? When it's stretched 0 degree, how long is the spring? You need to find how compressed, you need to find the compressed distance multiplied by the spring. You need to work a little bit. This one you need to think a little bit on the spring. Moment is quite direct. Moment quite direct. Moment degree is in radian. Radian. So you substitute all the value and then add the 3 work there. Spring work always negative. Okay, spring work always negative because no matter you press or you stretch it, you always get the opposite direction of your displacement and force. That's why you get negative work. Okay. How to get half ks square? Because the force of the spring is what? K half kx, right? Your spring force is half kx. Multiplied by the distance traveled, you get half kx squared. These are the fundamental. Okay. Okay, so by now you should be able to call what is kinetic energy, half mv square. If there's a moment, you need to add half I something lah. Okay, I omega. And spring, you need to recall back. Okay, so this one is your homework. Go and have a look. Okay. Okay, next lecture we continue with work and energy. Yeah.